In today's lesson, we're going to have a look at reviewing Boolean algebra, and we're going to look at Boolean expressions, we're going to look at logical circuits, logical gates, we'll have a look at logical circuits we need to know, such as the half adder and the full adder, and we'll look at Boolean simplification along with Carnot maps for also simplifying logical circuits. And the first question we look at is this one here. It says, we have a truth table. Truth tables, as we know, are ways of expressing inputs and then what are the different kinds of outputs we can have there. A and B are resulting in these outcomes here. Can we see what type of logical gate you'd use for that? Exactly right, exclusive OR, because 0 and 0 is resulting in a 0. 0 and 1 is a 1. 1 and a 0 is a 1. A 1 and a 1 is a 0, so it's exclusively working as an OR gate. And if it was it's an exclusive OR gate. If it was just an OR gate, what would be different?
The 1 would be 1.
Yeah, the bottom will be a 1, exactly right. And so it's asking us to write the logical expression. I'm going to interpret it as the Boolean expression. So it's saying S equals what? A. Yeah, so how do we write XOR?
V with a line under.
Yeah, so it's a V, and that would just indicate a OR, and the line underneath, exactly right, means it's exclusively OR. And then let's have a look at C. So C will be looking at what inputs?
And.
The A and the B. You're right, and is the answer. Spoiler. So 0 and 0 is a 0. The only place is a 1 here is when they're both on, yes, which means it's an AND gate. So how am I going to write that out, Moksh?
C is equal to
Yeah.
A
Yeah.
and.
Yeah, how do you do AND? Do you remember? So it's like that way around, isn't it? And remember, the tools to remember it is you can remember it, it's like an AND, because it's a bit like an A.
Okay.
I remember the V as OR versus, and then it's the opposite way around for AND. Anyway, C and B. Next question over here. Use the expression for S and C to draw a single logical circuit. And if we look here, what logical circuit is it we're dealing with right now? A half adder. S would be the sum, C would be the... So if you add 0 and 0 in binary together, you'd have no outcome and no carry. If you added a 0 with a 1, it would be a 1 as the outcome, but would it have a carry?
Nothing.
No. 1 and a 0 would be 1 and no carry, but if you add a 1 and a 1 together, it would make 2. So you wouldn't write down 0, you carry that over with a 1, and with a 0. It's a half adder. So if we're drawing it, we start off with the... Apologies for my drawing abilities, okay? So you start off by having the A and the B inputs. A and B are coming together into what gate? Into a XOR. So it's up to you which way you want to do it around. Let's do it this way first then. If you remember, an XOR gate was like this. Oh, that's bad, isn't it? Oh, actually, well, it's just, I'd make it a bit curvier because you want to make sure, although I suppose it's got that thing at the beginning. And that's coming up there. What outcome is that?
S.
There you go. And what else do I need to do?
Carry.
Yeah, what's the carry? What's the one for the carry?
A and B.
So it's, and what gate? And, yeah. So we do an and we've got this A. You can do one of these things and just jump over and then one of these, and it goes in here, and then that outcome would be C. Obviously, my drawing abilities are, I've lowered my drawing skills so that you guys don't feel bad when you do your own drawings. That's why you're welcome. So this time we're now looking at a Boolean expression here. That one we didn't do earlier, the arrow going in. What does that mean? Or the, sorry, not. That means not, exactly right. And remember, each section of the Boolean expression is split up with the OR. So we're doing A and B. So this is where A and B are true. And we'll see that where?
In the third column across.
Yeah, going across. So it's everywhere where A and B is 1. So we'll go 1, 1, 1, 1. We'll then look at the next one. In fact, oh, do you know I can do this? I've got all the colours. Boom. So what about this one? Not A and B.
Next to it.
Yeah, so not A would be when A is 0 and B is when B is 1. Yeah, you're right. No, you're right. I don't know which way around you.
Right, no, the left, no,
It's my left, I don't know.
To the left, to the
It's
left.
right. It's right.
And then, no. So now we're doing not C and not D, and that is quite straightforward because that's there and there. And we can draw. So the rules are to simplify an Acano map, we have to make shapes either 1, 2, 4, 8, or 16 in size. And we can see one big one here. We can make one shape there, and the other one we can see is yeah. So we could make, of course, two individual squares on their own, but the thing is we always need to make the largest available. So in this case, we want to make the largest possible, so we will go across like this, making that. And so now we just have to make what these two things are. How on earth do we do that?
The first one was not A and not. No, not.
So by the first one, do you mean this one or the big one?
The one across.
The one across. Oh, miss.
Hello, I made it in the end.
Oh, awesome. Oh, you're very welcome, miss. So we've got, that's not C and not D. Yes?
Easy.
Easy. All right, okay. What about,
It's very curvy.
hey.
It's just B. It's B. It's just B.
It's just B.
Your happiness and joyfulness is obviously wonderful, but like, let's, how did he get there? So what we're looking for is we're looking for where things don't change.
B.
So A is 0 here and 1 here, and therefore it changes. C is either 0 or 1 here, so therefore it changes. D is 0 or 1, so it changes. And in this case,
B.
B is consistent, so therefore
B.
I'm going to write down or D or B, and then you correct me. What do I need to change?
Brackets.
Brackets.
Yeah, quite right.
Easy.
There you go. All day, easy. Well, in that case, I'm joyful for you guys.
Easy.
Okay, well, the first one, yes. So that's not, where are we? That's not something, and therefore it is,
So
It's
something.
and therefore the something in this case being
A.
A. Now, this one here, do you remember when we did Boolean simplification, there were a few rules we had to learn, but one of the major ones was named after a certain person. Do you remember that one?
DeMorgans.
DeMorgans Law. DeMorgan, not any old Morgan, it's DeMorgan. And do you remember what it was, though?
Yes.
Yeah.
If you have a not above an A or a B, then it becomes not A and not B.
So- So, in this case, the and sign here would flip and become a or, and what else did you flip?
And you put the not outside the brackets.
Yeah.
Get rid of not.
Take it away from the A and the B.
Okay, so how are we going to write this one out?
Not bracket A or B. Bracket.
Oh, whoa. The bracket we're not going to have on this one here because we're going to go the other way around because, well, if you look at it, we've got, DeMorgans would be that, something like this. Not, you're talking about not A or B, yes. What would that become?
A and B.
Not A, so I was saying, and not B. Okay, if we're looking at this one here, we've got a slight change because, we could also do something like, we've got not A or not B. What do we think it's going to end up as?
Not
Hmm.
A or B.
In fact, doesn't that,
There's not.
what does that look like?
It looks like that.
The correct answer.
Yeah.
In fact, it's basically DeMorgan's Law, but of course they go both in both directions. So that looks like that, does it not?
Yeah.
Yes.
Eerily familiar, and therefore the answer is what?
Not and then A or B.
Not A or B. Could I leave the bracket out?
No.
No.
If I left the bracket out, what would I have to do?
You
Not
have
Put the
A.
bracket back in.
There's no way around fixing it. What about this one then, Treasure? What about that?
I can't see because
Ooh.
Hey now! So DeMorgan's Law applied on this means that it will become not A or not B, but we've got double not going in here, which negates itself, and therefore it becomes what in the end?
A or B.
A or B. Beautiful.
Yay.
Saying not so many times sounds like it's not a word.
So this is, let's be honest, the kind of questions of nightmares, right? If you see this question come up on your test, you get that sinking feeling, the water in, you feel bad.
You're like, oh no.
You're like, oh no. But don't worry, now we will all metaphorically hold each other's hand and we will go through this.
I didn't consent to that.
In this case, we're going to look through this one here. Now, that's obviously a complicated Boolean expression. What do we start with, do you reckon? Well, no, it's worth, guys, it's worth saying, would a Kano map allow us to solve this problem?
Yeah.
Yes.
Yeah, it would. If you used a Kano map to solve this problem, do you think you'll get the marks? Now, technically, what you could do is use a Kano map to check whether you got the answer right.
You can't use kind of map.
I'm saying you can't. You have to use the rules, but the Kano map
In
would
the
allow you
text,
to check
would
if
they
you were
make
correct. Yeah, they would. Yeah.
Oh, why?
Right. Jesus. So we're already seeing some things.
Oh.
So you're talking about the absorption rule, aren't you?
Yeah, I think it's just B.
Okay. So with this one here, that's not about past the state. So on this one here, absorption rule states if it's something. In fact, maybe it's worth writing out x and in this case x or y. That becomes, with the absorption rule, becomes x. And we can see that there. That's how the absorption rule works. In that case, that's become b. Boom. Finished?
No.
No.
Simplification.
Can we use the absorption rule on this one here?
No.
Why not?
You have three different
Yeah.
buffers.
Bingo. Agree with you. So what do you think we're going to have to do first?
Open the
Bracket.
The distributive rule. See, that's why I wrote the stuff down. So we can distribute that one out. So we can say,
A and B or A and C.
yeah. Let me write out the first bit. A or B
A and B.
A and B. In fact, let's do it like that and make life easier. And then A
And C.
and wait.
And B.
Wait. I'm doing this one, aren't I?
Yeah.
Yeah.
A and
And
C.
G.
So the first one is
You go for B first and you go for C.
A and B. If what I said is that for some people, especially if you do maths, this is actually a lot easier than for other people.
I do maths. It's
Sorry, I
hard.
hate it.
Yeah.
Well, you must suck at math.
I do some maths.
This, in fact, maybe let's make this even clearer. This bit that I've underlined in blue is now that bit in blue. Yes? This bit is all this bit, and you're quite right, I'm also a sinner, or B. And how did we get that B reduced? By using what rule? Absorption rule. Absorbed it in. Now, looking at this one here, there's actually quite an obvious one you can remove.
Yes.
Michael's going to do it, because he says he's found this hard, so he's going to do
I
it.
was just going to ask, do we remember the rules?
No, but I think it's helpful in terms of when you're doing the revision to
Can't you just scrap
But there's not
the
going to be a question
A
of
and
what.
DeMorgans Law. They may ask you to demonstrate how DeMorgans rule works. Absorption, cumulative. Well, they don't reference them directly, and I've never seen a question that asks you. They just ask you to use the techniques. Right, Michael.
Well,
There's something very obvious here.
oh, yes.
What do you see?
A and B, there's A and B.
There we go. Beautiful. I knew. So because A and B shows up twice, A and B's here, or A and B. Do we need both?
No.
No. So we can literally just go.
Get out of here.
There we go. And we've reduced it some more. So that's a wonderful thing.
You should get rid of the other or as well, because then it's going to be A.
Yeah.
Oh.
There you go. So let's write it out again. So we've got A and B. And I'm going to write this here, or B. So I've stuck that one over there. Or A and C. Now, what else can we see
The
here?
first one becomes just B, right?
How does it become just B?
Absorption.
Absorption rule. So here it was X or X and X or Y. But if you flip them around,
Oh, okay.
it also works. So absorption rule means that that was the first way around. But if I'll write it in blue. It also could mean X or X and Y could also become. There you go. And you see that's what's happening here. Orbitally, I've got the B on the other side, but that's what's happening here. So that becomes what?
B.
So we've got B or.
A and C.
Beautiful.
And now we can check Ricardo map.
Yes. Tell you what, later on, what is it? A full adder. Now,
Big snake.
a half adder, does that allow you to add together allow you to add two Boolean numbers together? A half adder?
Yeah.
Yes, it does. What are the limitations of the half adder?
Ooh.
You can't add the carries.
You can't add the carries.
2 bits.
Yeah, so you could only basically add 2 bits together. You can't just stuck them together unless it was always 0, 0 or 0, 1 or 1, 0. If you ever got a carry, you've had it. And so this is why the carries come out here, and then it's going to be input into the next one there. So what does... Oh, actually, I feel like this one here, if I'm being honest, that feels a bit too straightforward. No?
How many full adders would they have on a board?
How many full... Well, if let's say it was doing a 64-bit number,
Yeah.
yeah? So if it was adding two 64-bit numbers together, how many full adders do we need?
One.
Well, each full adder allows you to add together two numbers. If we've got a 64-bit number... Okay, fine. Let's start smaller. 8-bit number. A 4-bit number. I want to add a nibble together, right? A nibble. Each full adder allows me to add together two numbers.
Yeah.
So if I wanted to do a 2-bit number, I'd have to have two adders.
Yeah.
If I wanted a 4-bit number, I'd have to have...
Four.
If I wanted to have... That was for extra. I like that. If I had a 64-bit number, I'd need to have...
64.
Yeah. 64 full adders.
Yes.
Yeah.
That was me. Easy.
So let's explain what it... I don't know if that's worth doing, this bit over here, if I'm being frank. Let's do this bit here. Let's explain. So what sort of things does it do? We're saying... So takes in A, B, and carry in. What's it do with it?
Add them together.
Okay. Adds the result. Yeah, well, of the three, because it's have to take in all three as a result, couldn't it? Of the three, and then outputs the sum and C out. Now this is worth 4 marks. Do you think we've got all 4 marks at the moment?
No.
What's something that do you think we might say about it? Do you think it's worth saying
What each part does.
this is a full adder?
Yeah.
That's worth saying, right? And I think what we're going to have to do is go into more detail, as you say, about how the XOR gates and the AND and the OR gate work together to actually develop the whole thing, which is why I've kept in the exam question, kept in the answer on the next page for us to review it. Boolean expression for S. Remember, what we want to do is we want to start from inside first. So that's the first one we want to do. So what's that going to be?
XOR bracket A XOR B.
A, how do you do XOR?
B,
B, what's next?
and then XOR C.
So it's this one we care about, isn't it? XOR C, yes?
Yeah.
Yeah.
Everyone sounds very...
Yes.
Confident, yes.
Oh, good. You've upped your game.
Yes.
Done. Yeah, done. What else? What about C out? So C out's down here. So these gates have to be we have to populate these, and then they combine into that, which is the output. So what goes into this one?
XOR A and B. A and B.
XOR A and B is one of the inputs, isn't it?
And
C in.
Yeah.
Wait. I can only do limited person. Can't do right. What about it?
Bracket and
So it's going into the AND gate with what?
C.
C in.
C in. What else do we need to do?
Bracket that.
Bracket all that up, because that is going to be the incoming for this one. Or in between it, quite right. Or, and then it's...
A and B.
So we see here, coming into this one here is A and B. Or A and B. Too easy, guys.
Easy.
Easy money. We said that we were going to review this, so let's have a look about how we get those 4 marks for the description. Circuit adds 2 bits and a carry bit and is an adder. Oh, there you go. So you're saying it's an adder. In fact, it's a particular type of adder. It is a full adder. A, B, and C in are added together.
We did that.
Yep. The result is given an S
Yes.
and a carry bit. To be fair, actually, that's
We did that. We didn't bullet point. We just.
yeah. I think we're all right.
Smashed it.
What about this one? Good. I think they've made a mistake by not including the brackets, though, personally. But yes, and that one, that is perfectly done.
TLDR, they suck.
Last question I'm going to do about Boolean algebra, and then we're going to break out to do our different areas. Draw a logical gate for this one here.
Yes.
Here's the tip for logical gates, is that you always do the logical circuits, you do the gate first. So what's the gate?
And or.
So I'm going to do, in fact, I'm going to do my A I'm going to do my B, and we've definitely got an or. Again, don't be too blown away by my drawing ability. Not everyone can draw as well as I can, so I get that.
Yeah.
So what's on the A?
Not A.
Not gate. Yeah, so not gate.
Triangle with a little circle.
Oh my god.
Yeah, some say it's Picasso, but
Yeah, exactly. It's all impression. And then what happens with these?
They go in the
go into the thing.
There you go.
Backwards cube.
Boom. Beautiful. And then a final one, simplification of a Boolean, of this one here.
Yes.
Piece of cake. Yes? Mox is going to do it. Go on, Mox.
What is it? Like fiber?
It's a Kana map, it.
Okay, yeah.
So Michael's favourite thing in the world.
Yeah. Better than literally anything else.
You go over the first line.
So we go over the first line. So I'm going to just use this to do my groupings. There we go. What else?
Like last column.
Done. Stop with the sniggering over there. Yeah, what else?
And last two. A second row, last two.
Second row last. So
You could have a 4.
you're talking about this and this. Yeah. So this is worth saying. It's worth saying. People, could I just put one box around that one thing there? I could. And I could do one there. I could do two there. I could do two there. What is the aim? What is always the aim?
Largest.
Most simple.
Yeah. The box as big as possible, because that's going to allow us to have what in the end?
Specification.
There you go. So in here, we want to make it... Oh, sugar.
Big 4.
We want to make it... and then... now we have to figure out what it is. So we're looking for what stays the same and what changes. So this one here, that is...
Not C, not D.
So that's not C
Not D.
and not D.
Or
Which one do we want to do? Let's do this one down here.
A.
A and not B.
Beautiful.
Or
Or is it
A.
Yeah, what's this? So it's what stays the same.
A
and B.
A.
and not C.
Not C and A. Not C and A.
A and not C. A and not C.
Not C and A.
A and not C.
Not C and A.
Told you that.
Beautiful. Obviously, this is meant to all be on a single line, but I'm a bit of a klutz and made too much space for it. People.
Donatello, but